How many have ever heard that word before? None. Okay. How many people from the Bahamas? Anybody from the Bahamas here? How many people have been to the
I
Bahamas?
live in Bahamas.
Okay. The sands are white, very white sands. They are oolitic aragonite, which is calcium carbonate taken out of solution, out of the ocean itself, built around a nucleus of a sand grain. So that's why they're all round, they're all white, they're all really, it's a beautiful beach, beautiful beach. But that's what this is in the back reef. And that developed, and then at the end of that period between 10,000 and 120,000 years ago, so that's a long time span, that's 110,000 years, it starts getting cold. And the water, the oceanic water started to be occupied in the glaciers. The glaciers started to build up tremendously. And in that process, the corals start to erode as they're exposed by the water being occupied by the glacier. At their present sea level, you have the oolitic, and then you have the shell material here. Carbonate sediments resulted in concentrations in cementation of the grains as they get exposed. So you have something called the Miami Formation, Anastasia Formation, and oolites. How many of you have been to Matheson Hammock? You been there? Next time you go, look for it under the detritus in the forest. Okay? You'll see exposed limestone. Those are oolites. That's part of that formation. And then finally, about 10,000, well, we have a full, at this point in time, we have the full glacier, last ice age, where the glaciers were as far south as the Carolinas. So that's a lot of water that's used up. The water was 300 or 350 feet below today. So the reef picture that I showed you, the maps that I showed you, the water level was east of that, way east of that, in about 350 feet of water, 300 to 350 feet of water. One little quick story, blue holes. Anybody seen a blue hole or gone diving in a blue hole? No?
We got one here in Zuma. They have it.
Yeah.
Yeah.
Well, they have blue holes in, you have?
Hawaii, yes.
Yeah, okay. When they formed at this time, during the glacier period. They were sinkholes. Sinkholes of exposed limestone. They sink down, the sinkhole fills with water, and as the glacier starts to melt again, the water level comes up, and you have, as the reef builds up around it and around it and around it, you have a blue hole. They're beautiful blue holes in Case Sal Bank that I've been diving in them. So now the other thing you have here is the talus, or the broken up old reef, and the Anastasia Formation, and the cemented sediments. And keep that in mind that it's still there. Then about 10,000 years after that, about 10,000 years ago, the climate changes. The climate changes and the glaciers start to melt. Remember, the climate changed. Okay? It changed. It changed over 10,000 years. It's still changing.
So you're saying that 10,000 years ago, Florida was covered by glaciers?
No. The glaciers only went as far south as the Carolinas.
But they started to melt, okay.
Yeah, and our Florida was much, much larger at that time because the water level was maybe, instead of 2 kilometers offshore, the reef, 2 kilometers offshore, the reef was this way out here and about 3 or 4 kilometers offshore. And then glaciers started to melt, water levels started to come back up again. Conditions are perfect way offshore for reef construction. That's the first, the outer reef, okay?
Third reef.
Yeah.
Since we've been talking about the sand and the fish excrement, I'm gonna regret asking this, but if it's all calcium carbonate from the reef, why is the sand in Bermuda pink if it comes from the reef and it's a coral?
Well, the sand in Bermuda is pink because it's
Calcium carbonate coming
it's
down?
calcium carbonate, but it's also it has a tint to it from other minerals.
Oh, okay, it's not just coming, okay.
No. And then you have all kinds of sands in the world.
Right.
In Hawaii, you have black sands
Yeah,
from
yeah,
lava, lava,
yeah, that I
and
know.
green sands,
And red sand.
huh?
And red sand.
And red sands.
Are
Yeah.
all sands made from the fish?
No, not all of them. So about 50% of the sand that we have on our beach here comes from the Piedmont Plateau and the not Adirondack Mountains, the
Appalachian?
Appalachians, yeah. And through process of river erosion of granite rocks. And that's
Oh, the
silicate,
pieces of rock. That's what I thought it
salacious
was.
sands.
That's
It's
what I thought.
silicon.
Silica, it's,
Yeah.
if you melt it, it makes
Yeah.
glass.
And we have a lot of that right here in Florida. There's
Okay.
silica mines in Florida.
The
Okay.
Florida sand is all
That's what I thought.
basically like whitish or that tannish.
Florida sand is a combination of silica and calcium carbonate, roughly 50-50.
Thank you.
Now, 6,000 years ago, the glacier, it's warming up again, climate is changing, the glaciers are melting, sea conditions are perfect for the coral and the offshore. This is the outer reef, the middle reef starts to build. You see the sand depositing in behind that from normal erosional processes.
So now we have the second and the third reef, right?
Pardon?
So on that slide, we have the second and the third reef, right?
Yes. And now you see the first reef ridge here, and then what you see here is the corals
So it's
start to
actually
die off underneath. And what you have growing on top is live, healthy coral growing on top of dead skeleton.
So actually, the first reef is the first reef that started, because
The outer reef
the outer reef.
is the
And it
first reef that
died.
started, and it's the oldest one.
It died because the water got too deep for it to have.
Well,
It didn't die.
that's part of it, yes, but you still have a layer of healthy reef on top of old skeleton, old deposits. And sea level continued to rise 4,000 years ago, and then 3,000 years ago, you start to have the ridge complex starts to get colonized, and this is the inner reef, and then this is the colonization of the Anastasia Formation below there. And sediments continued to accumulate in between the two reefs. These are the big sand areas that I showed you about on that map. And occasional storms caused production of rubble, which was deposited from those layers in the sediment troughs between the reef structures. And now we're back to present sea level. And we're going to talk about climate change in a minute, because over the last 150 years, the rate of sea level rise and the rate of climate change has skyrocketed from our use of fossil fuels and the warming and the production of calcium carbonate, CO2. Now, how do we find out some of these things? How do we find out about the reef? How did we find out how old this reef is out there? Well, remote sensing, water sampling, and studying the contents of those water samples, coring the reef, coring colonies of coral, individual colonies. And you'll see in the back of one of the posters right back here, a colony that goes, it's right offshore of Hollywood and still alive. And I don't know if you've ever seen it, but it's about 4 or 5 meters in diameter and about 4 or 5 meters high. And it goes back to 1683. Yes?
When you say studying the water, give me an example.
Measuring oxygen levels, measuring CO2 levels of the water, measuring the salt content of the water.
Okay, I'm trying to put it in more perspective, say that I had fifth graders
Yeah.
measuring the water, what, can I go to like different beaches and?
Well, you just tell them that they're
Cup of
measuring the
water?
chemistry and changing of the chemistry and the water content. That would be a simple explanation. Another way of measuring health of the reef is by using transects. Transect tapes. You can see this diver is taking a video of a transect. There's the tape. And you go back to that same location, you put a stake, a piece of steel at one point, another piece of steel at the other point, measuring tape in between, and you count everything that's on that tape, that's touching that tape. That's a transect measure. Or you use cameras and take a video or a picture document of the individual colonies that are there. And we can go back to the same place, the same location, the same colony. Number one, check and see if the colony's still there. Number two, check and see if the colony is healthy. Has it grown? Is it growing, and what pace is it growing at?
Do you use GPS for that?
Huh?
Do you use GPS for that?
GPS? Yeah, absolutely. GPS was particularly when they let the military version of GPS be used by civilians. So it's very accurate GPS that we use. The GPS is survey accurate, so plus or minus 2 centimeters. So we get right on that spot every time. Yep. Okay. And there are computer programs now where you can scan in the shape of that coral colony and check it periodically to see where it's growing, or if it's eroding, or if it's dying, or if it's healthy. We also go out and look at the diseases that corals have. What are some of the environmental and management issues for corals? There's your picture of turbidity. Okay, this is a dredging project at Port Everglades. And the corals are being impacted by the fact that conditions are no longer optimal for them. And they can expel their zooxanthellae if they're too stressed from conditions like that. Physical impact. During the time that I worked for Broward County, there were, I think, 17 different ship groundings right offshore here, because we have a huge Port Everglades harbor and ships waiting to come in for dockage would anchor out there. Sometimes the anchors break, sometimes they make mistakes. Now, when that colony or that reef environment becomes damaged like this, it takes roughly 400 years for that to recover. Okay? Some scientists will say more, some scientists will say less, but on average it would take about 400 years for it to recover.
But
Invasive species, oh, go ahead.
the recovery is never 100% pre-position, right? Like,
Well,
it'll recover kind of like you heal a scar.
Yeah,
So your skin will never be exactly the same. There'll be some markage, some damage eternally, but
where you're going to see it is the base substrate itself. If that is damaged, it never completely recovers.
it will grow over that kind of scar
Everything will-
eventually.
Eventually it will grow over, and that's why they say it takes about 400 years for complete recovery. Yeah. The reason is that one of the things that I didn't say yet is coral polyps, most coral colonies that are stony corals, the scleractinians, only grow about half a centimeter a year. That's it. And that's how, when we take a core of it, that's how we can determine that they deposit their calcium carbonate in 2 different densities. And in August, in the hottest part of the year, the density is very, very concentrated. And in the rest of the year, it's less concentrated, so they have a ring, just like tree rings.
Like, yeah, I was just
Yeah.
gonna say.